Each of the middle group of problems has a duplicate parentheses, and when problems have duplicate parentheses, they can be solved by something called U-substitution, which is kind of a cute way to solve the problem that doesn't seem legal. To solve the problems between 11 and 19, because I deleted problems 7 through 10, I'm going to follow these steps. They don't always teach this strategy. There's another way to do this, but I'll try it this video and see how it goes. So for numbers 11 through 19, I'm going to first change the parentheses to the letter U. So it's super common in calculus to do something called U-substitution. So in problem 12, for instance, my first step would say to do u squared plus 6u minus 7. What I've done is I've changed the parentheses of x minus 5 to a u. That's what the first step would tell me to do in each of the problems between 11 and 19. 2, solve for u by, forgot the equals to 0 over here, there's still this right hand side, by either factoring, if you can factor, or the quadratic formula if you don't feel like factoring, or if it's not something you could factor in your head. Factoring and the quadratic formula give exactly the same answer. If something factors, I prefer factoring. For number 12, this factors into plus 7 and minus 1. If you can't factor to get your answers, then use the quadratic formula. So step 1 was to replace the common parentheses with a u. Step 2, I'm going to solve this equation either by factoring or the quadratic formula. They'll give exactly the same answers. I factored, said each of the factors equal to 0. Got my answers for u. Step 3, I'm going to take my answer for u and substitute it back into the u equals to solve for x. The answers for u aren't the answers to the problem. So I'm going to take this one and sub it into there. So I'm going to use the u equals x minus 5 and go negative 7 equals x minus 5, substituting into the u equals, and 1 equals x minus 5, substituting these two u's separately into that u, and I'm finding the x. For this one here, I'm going to add 5 to both sides. On the left hand side, the numbers have opposite signs. On the right hand side, the numbers cancel. For this one, I'm going to add 5 to both sides and get what I think are answers. I think my answers are x equal to negative 2 and x equal to 6. Turns out that this strategy for solving doesn't produce extraneous solutions, but it's always safe to check your answers because it's not particularly hard to check, so I'm going to check. I have 2 different answers, and for the checking, I'm going to use the original problem, x minus 5 squared plus 6 times x minus 5, or x minus 5, minus 7 equals to 0. First I'm going to check negative 2 and see if negative 2 minus 5 squared plus 6 times negative 2 minus 5 minus 7, see if that equals to 0. So on my calculator, parentheses, negative 2 minus 5 squared plus 6 parentheses negative 2 minus 5 minus 7. This gives me 0 equals to 0, so negative 2 is a solution. Now I'll do the same with 6 and see if 6 minus 5 squared plus 6 times 6 minus 5 minus 7 equals to 0. And it should work. On these U problems, usually everything works. Usually I don't get extraneous solutions. So 6 minus 5 squared plus 6 times 6 minus 5 minus 7, and I get perfect. So both of them are solutions. Let's do 13 together. I'll skip 14. First step in 13 is let U be the common parentheses. So when we have common parentheses, this U substitution is an acceptable way, slick way to solve. So I'm going to rewrite the problem as U squared plus 6U plus 5 equal to 0. So step 1, change the parentheses to the U. Now I'm going to solve by U by either using factoring or the quadratic formula. This is easy for me to factor, so I'm going to factor this. This factors into plus 5 and plus 1. If you're slow at factoring, quadratic formula and factoring give exactly the same answers. Not giving as much detail in my factoring, assuming that if you can't factor, you're pulling out the quadratic formula and that you can do that. You get exactly the same number answers if you use the quadratic formula than if you do factoring. So I solved by factoring. You could have solved by the quadratic formula. My second step, I solved for U. Third step, take these answers and plug them in for here. So I'm going to use the U equals 2y plus 5, and first do negative 5 equals 2y plus 5, and then do negative 1 equals 2y plus 5. I'm taking the answers for U on the third step, shoving them back to that equation. Now I'm going to do my algebra to get the y solved for. So for this left one, I'm going to minus 5 from both sides and get negative 10 equals to 2y. Divide by 2, and get negative 5 equal to y. For the right one, I'm going to minus 5 from both sides. Those have the same sign, so I add them. I get negative 6 equals to 2y. Divide by 2. This gives me negative 3 equal to y. Don't really have to check, but I will. My answer should be y equal to negative 5 and negative 3. For the checking, I should go back to this problem right here, and I want to check the y equal to negative 5. To do that, I'll do parentheses 2 times negative 5 plus 5 squared plus 6 times 2 times negative 5 plus 5, and then plus 5 equals 0. That has to be 0 for this to check. So to check this, clear this out, parentheses 2 times negative 5 plus 5 squared, that's my first parentheses, plus 6 parentheses 2 times negative 5 plus 5, second parentheses, plus 5, better equal to 0, which it does, so that works. And then my second checking, I do 2 times negative 3 plus 5 squared plus 6 times 2 times negative 3 plus 5 equals to 0. I just need to go into my last lines and change the negative 5s to negative 3s rather than typing the whole thing again. And that also gives me 0 equal to 0. Solving with U's doesn't give extraneous solutions like solving with square roots. Couple more problems to do. These are going to be a little bit uglier because I might get some fraction answers, which are a nuisance to check. I'm probably going to pull out the quadratic formula. I'm going to do 16. Then I'll do 17, and maybe we'll call this video done. So I'm going to let u equal to x minus 1 and get 3u squared plus 5u plus 2 equals to 0. I'm going to quad formula this. I'm going to go A equal to 3, B equal to 5, C equal to 2, because that's hard factoring. And I'm going to go U equals negative B, which is negative 5, plus or minus the square root of B squared. B's positive, so it doesn't need to be in a parentheses, minus 4 times A times C, all over 2A. Let me get this square root finished. So the square root of 5 squared minus 4 times 3 times 2. The square root simplifies to be 1. And the denominator comes out to be 6. So I need to do U equals negative 5 plus 1 over 6. And U equals to negative 5 minus 1 over 6. This first one comes out to be 4 over 6, which is 2/3. The second one is negative 6 over 6, which is negative 1. So I did the first two steps. I changed the letter to U. I solved for U. Now I need to substitute back in to solve for x. I need to substitute back into this. So I need to go 2/3 equals x minus 1. And I need to do negative 1 equals x minus 1. I need to solve each of these for x. The left one, I add 1 to both sides. This gives me x equals 1 plus 2/3. Let me just lazily do this. 2 over 3 plus 1 is 5/3. And the right one, I'm going to add 1 to both sides and get 0 equal to x. I think my answers are x equal to 0 and 5/3. Let me try to check these. So for checking, in problem 16, the original problem is 3 times x minus 1 squared plus 5 times x minus 1 plus 2 equal to 0. Let me do the 5/3 first. So I'm going to do 3 times 5/3 minus 1 squared plus 5 times 5/3 minus 1 plus 2 and make sure I get 0. So clear 3 parentheses fraction 5 over 3 minus 1 squared plus 5 parentheses fraction 5 over 3 minus 1, close my parentheses, plus 2. I better get 0, and I didn't. So I have a math error, or I didn't check right. Let me try to do the checking first. Crikey. I don't know where my mistake's at. Oh, I see my mistake. I blew a sign right here. This negative 5 plus 1 should be negative 4 over 6, should be negative 2/3. So this should be negative 2/3 plus 1. I should have done this. Negative 2, fraction, negative 2 over 3 plus 1. This is a benefit of checking. My answer should be 1/3 and not 5/3. Let me check this now with a 1/3. So that's the good thing about checking. So now I can know if I made a math error. So you don't have to check, but if you make a math error, the checking is going to show you that you made that math error. So changing the 5/3 to 1/3, I magically get what I need to get, 0 equal to 0. So that checks just fine. Let me check the 0 and see if 3 times 0 minus 1 squared plus 5 times 0 minus 1 plus 2 equals to 0. So 3 times 0 minus 1 squared plus 5 times 0 minus 1 plus 2. and I get 0 equal to 0. So great idea to check, but you don't have to check. Let's do 17 together, and I'll save you 19 and 15 for homework. Do all the odds in this section. And I'm going to do 17 on a clean sheet of paper because I'm running tight on room here. So 17 is 5 times 3x minus 1 squared plus 7 times 3x minus 1 plus 2 equal to 0. First, let u be the common parentheses and make this 5u squared plus 7u plus 2 equals to 0. Now use the quadratic formula and go u equals to negative b, which is negative 7, plus or minus the square root of b squared, which is 7 squared, minus 4ac, which is 4 times 5 times 2, over 2a is 2 times 5. Under the radical, I have the square root of 7 squared minus 4 times 5 times 2. The radical simplifies to be 3. So this is going to be u equals negative 7 plus or minus 3. The denominator is 10. So I get negative 7 plus 3 over 10 and negative 7 minus 3 over 10. The first one is negative 4 over 10, which reduces to negative 2/5. The bottom one is negative 10 over 10, which reduces to negative 1. That's kind of the end of my step 2. Step 1, I changed the parentheses to u. Step 2, I solved by the quadratic formula because it was cruddy factoring. Step 3, solve for x. So take these u's and plug them right there. So I'm going to go negative 2/5 equals 3x minus 1, and negative 1 equals 3x minus 1. For this side, I have to add 1 to both. On the left side, I need to do fraction negative 2/5 plus 1, which is going to be 3/5. So this is going to give me 3/5 equals to 3x. And then divide by 3, divide by 3. So fraction 3 and the 3, like this. Fraction, fraction. So the numerator is 3/5. The denominator is 3. That gives me 1/5 because this part right here, this is 3/5 divided by 3. That's the same thing as 3/5 times 1/3. Dividing is the same as multiplying by the reciprocal, and the 3's cancel. So this is going to give me 1/5 equals x, that I'll check here in a second. The other side, I just plus 1 and get 0 equals to 3x. Divide by 3, divide by 3, and get 0 equal to x. I think the answer is x equal to 1/5 and x equal to 0. I should check, and in order to check each one of these, to check the 1/5, to make sure I didn't make a math error, I should go 5 times parentheses 3 times 1/5 minus 1 squared plus 7 times 3 times 1/5 minus 1 plus 2, and that should equal to 0. So for checking, 5 parentheses 3 parentheses fraction 1/5 parentheses minus 1 parentheses squared plus 7 parentheses 3 parentheses fraction 1/5, close out my parentheses, minus 1 parentheses plus 2. This better come out to be 0, and it does. So I've checked the hard one. And then for the 0, I'll go 5 times 3 times 0 minus 1 squared plus 7 times 3 times 0 minus 1 plus 2, and make sure that comes out to be 0. So 5 parentheses 3 parentheses 0 minus 1 squared plus 7 parentheses 3 parentheses 0 minus 1 parentheses plus 2. And that gives me 0 equal to 0. Solving by use, if you don't make a math error, the numbers are going to check. If you make a math error, then all bets are off. So should be able to do all the odds in that grouping that we didn't do between all the parentheses problems. So you should be able to do 11, 13, 15, 17, and 19. I did a couple of them to minimize your work. We've got one more style of problem to get through in this section. I'll pause the video and do a part 3.